Hi Stephen, we've just done a Meissner effect demo and it's really cool.
We heard you did your PhD on superconductivity, is that right?
Yeah, that's right. Sit down. Yeah, I agree that superconductors are pretty cool because of the three properties that they have. Firstly, superconductors have zero resistance. So what that means is that I can put a large current through a wire made of superconductor, but it won't waste any of the energy as heat. That means that I could make, say, an electromagnet using superconducting wire, put large currents through it, and therefore generate very large magnetic fields. Another property of superconductors is called perfect diamagnetism, or the Meissner effect. What that means is that the superconductor excludes all magnetic fields from within inside them. It shields out magnetism. And the third thing is superconductors have odd properties that allow me to make devices that are extremely sensitive to magnetic fields.
Does that have anything to do with maglev trains? We've heard of maglev trains and we were wondering if you could tell us more about them. Do they use the Meissner effect?
Now, maglev trains, or magnetically levitated trains, do use superconductors, so you're right about that, but they don't actually use the Meissner effect. Now, in the Meissner effect, what happens is if you bring a magnet towards the surface of a superconductor, the superconductor responds by creating a magnetic field that is a mirror image of that of the magnet. So as far as the magnet's concerned, it's as though there's another magnet with the same pole pointing back towards it. So there's a repulsion. The force of repulsion can exactly balance the force of gravity on the magnet, and so the magnet levitates.
Oh, I thought the superconductor made gravity disappear. But actually the magnetic repulsion balances gravity, and it doesn't break Newton's laws after all.
Because maglev trains levitate above the tracks, there's no contact resistance, so the train can go much faster, up to 580 kilometres an hour. Now, it might look like Meissner effect, but in fact, in a maglev train, you make large electromagnets wound with superconducting wire, so you can generate big magnetic fields. This big magnetic field is used to repel similar electromagnets in the rails. The big fields can be used to levitate, guide, and propel the train forward. Now, the only problem is trying to keep the superconducting wire below its critical temperature, which is why it would be really cool if somebody could discover a room temperature superconductor.
Well, it's very good to have a floating train, but there must be something else superconductors can be used for.
Actually, superconductors have lots of important applications. The most important probably is magnetic resonance imaging machines, or MRI, that you find in hospitals that can take pictures of slices of your body. This technique relies on there being a large magnetic field, which is provided by a superconducting electromagnet. In fact, whenever you need a large magnetic field but you don't want to waste a lot of energy, you can do this by using a superconducting electromagnet. Now, not only that, superconductors can also be used to make devices that can detect magnetic fields. Now, have you ever heard of squids?
Well, yes, but what do they have to do with anything?
No, I don't mean calamari. I mean superconducting quantum interference devices, or SQUIDs for short. These are little devices that are extremely sensitive detectors of magnetic fields. And they're so sensitive that they're actually able to detect the very tiny magnetic fields that your brain generates due to nervous impulses. And in fact, some people have done research on trying to measure electrical activity in the brain by putting squids on the outside of people's skulls.
Floating trains, seeing into people's brains. What's next?
So, you said superconductors have no resistance, right? And V equals IR. So does that mean you can have infinite currents going to homes?
Well, not quite, but it could mean great things for the way that we supply electricity to homes. In the traditional method for supplying electricity, there are lots of places where energy can be wasted. Just one example of how we could make this process more efficient is if we were to make generators using superconducting wire. These generators are much more efficient, about half the size of traditional generators that are wound with copper. We could also use superconducting wires as transmission lines, as power lines for transmitting power to your home, although at the moment this is rather unrealistic.
So do you think that's it for superconductors?
No, many more great things to come. For example, superconducting films could be used to further miniaturise computer chips and make them run faster. Also, some people are working on superconductors to make quantum computers. Quantum computing is an up-and-coming area of physics that could revolutionise the way that we do computing.
Wow, superconductors sound too good to be true.
Actually, there are a few challenges for young scientists like you. The limitations of superconductors include the difficulty in maintaining the low temperatures that you need to achieve superconductivity. Another limitation is the fact that the higher temperature superconductors are made of brittle ceramics, which are hard to shape into wires and other electrical components. Sometimes it's a compromise between critical temperature and the material properties that you need.
Well, I think we've learned a lot today. I didn't realise there was so much more to superconductors than floating magnets.
Yeah, thanks for sharing all that information with us.
No problems. Maybe the two of you will be part of the research team that will eventually discover the room temperature superconductor.